Hello, calculus students. This is Mr. Plunt. We are talking about 10b, area between the curves, part 2. Okay, this time we're switching things up a bit. Okay, first of all, we need to get introduced to the idea of graphing in the form x equals. Okay, this isn't terribly difficult, so here's a quick introduction. All right, let's plug in this is our input. We'll plug in things for y and see what we get for x, and then graph them. Let's put in -2. -2 squared is 4. Let's plug in -1. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, so we get 4 -2, 1 -1, 0 0, 1 1, and 4 2. Holy cow! It is a sideways parabola. Okay. So this is not a function. Functions are written in the form y equals. Not functions are x equals. Okay. How about x equals the square root of y? What might you think this looks like? Okay. So y equals the square root of x looks like this. Half of a sideways parabola. I wonder what x equals the square root of y looks like. Okay, we'll make a table. We'll pick stuff for y, see what you get for x. Let's pick -1. We can't take the square root of -1, so there's no answer. How about 0? Square root of 0 is 0. 1, square root of 1 is 1. Square root of 2, I don't know. Square root of 3, don't know. Square root of 4 is 2. Okay, so we get 0, 0, 1, 1, 2, 4. Holy cow. There's the square root graph. It's half of a parabola. That's half a parabola. That's half a parabola. Interesting. Okay, what do lines look like? Okay, x and y. All right, let's pick -1. So 2 times -1 is -2, plus 3 is 1. 0. 2 times 0 is 0, plus 3 is 3. So we get 1, -1, 3, 0. Let's plug in 1 just for good measure. 2 times 1 is 2, plus 3 is 5. So we get 5, 1. Yeah, and it looks like a line. Okay. So this 3 is now the x-intercept, and the slope is over 2 up 1. Over 2 up 1. Now, over 2 up 1. So this is the over, and this is the up. So it's kind of switched around. So I tend not to memorize. I tend to get my lines confused occasionally, so I tend to just make a table. They don't pop up that often, and tables don't take that long. Okay, but that's a quick introduction to graphing in the form x equals. Okay. We are moving on. Now, this one, y equals 2x. That's just regular y equals 2x. That's this line. Plus or minus 2 square root of x. The plus is the top half. Maybe I'll draw this out. So 2 square root of x. So what we've got, 2 square root of x, the plus is the top half, and the minus is the bottom half. Okay, so we got a sideways parabola, but this time it's written in function form. That said y equals plus or minus 2 square root of x. Okay, so if we find this area, the region bounded by the curves, so let's see if we can find this area. So this is a review problem from the last section. Okay, So our region clearly goes from 0 to 1. And the larger curve is on top. That is 2 square root of x. We ignore the negative. We don't need it. We don't need the negative. And then we're going to subtract 2x. Okay, so this goes from 0 to 1. 0 to 1. Now it's 2x to the 1/2 minus 2x. So I'm going to happily take this antiderivative. So I get 2 over the new exponent, 1/2 plus 2/2 is 3/2. X to the 3/2 minus 2 over 2, which is 1x squared. 2 divided by 3/2 is the same as 2 times 2/3, which is 4/3. X to the 3/2 minus x squared. Now we have to plug in 1 and 0. So 1 to the 3/2 is 1 times 4/3 is 4/3 minus 1. And then double check if you plug in 0, you get 0. Usually you do, but not always. Now 4/3 minus 3/3 is 1/3. Holy cow, we've done it. Okay, this bad boy. 1/2 y is that one. 1/2 y squared, 1/4 y squared is that one. Okay, now find the area of this region. It's the same region. But now it's written in the form x equals instead of y equals. So in this problem, the previous problem, the x's were the inputs. The x's were the inputs. So where does it go from? It goes from 0 to 1. Here, the y's are the inputs. So the y's are the inputs. So where does this go? This goes from 0 to 2. So the inputs go from 0 to 2. On the previous problem, the inputs went from 0 to 1. Now, here, the larger curve was on top in the previous problem because like the input of, say, 1/2. At 1/2, the larger curve is on top. Here, at the input of like 1/2, the larger curve is on the right. So it's right minus left. The right curve is 1/2 y. The left curve is 1/4 y squared. All right, so this is actually going to give us the same answer. 0 to 2, 0 to 1. Yeah, I mean, I think it should, but I don't know if it's looking promising. Okay, so we get 1/2 over 2 y squared minus 1/4 over 3 y to the 3rd. Okay, 1/2 over 2. 2 is the same as 2 over 1. So that'd be 1/4 y squared. Minus 3 is the same as 3 over 1. So that becomes 1 over 3. That's 1/12 y to the 3rd. Now plug in 2. 2 squared is 4. 1/4 times 4 is 4/4. 2 to the 3rd is 8. 8/12. Plug in 0 to double check you get 0. You do. So you get 1 minus, or you get, let's just go 12/12. Minus 8/12 is 4/12. You get 4/12. You get 4/12, which reduces to 1/3. Holy cow, they are the same. Okay, So we can integrate it where x's are the inputs or y's are the inputs. We'll have a choice on the test. Okay, so keep track of the formulas. They're essentially the same, but you're like kind of looking at the y's sideways or something like that. Okay, so it's basically the same formula. Okay, let's try this bad boy. Find the area of the region enclosed by, are they kidding? That looks terrible. So y squared is a sideways parabola. It's a sideways parabola, like I don't know exactly where, but like that or something. I mean, I don't know where it goes from. Now, negative y squared, that's a sideways parabola, but it's flipped sideways. So the negative y squared one would look like that because it's negative. The positive one we just learned up above, open to the right. So we have two choices. We could graph these accurately because we need to know where they go from. We need to know this value and this value, where they go from on the y-axis. Okay? So we have two choices. We could graph it accurately, which sounds like a bear. In this problem, it says we can sketch the curves. We don't have to. I like the idea of solving it algebraically instead. I bet they cross at nice whole numbers. I bet we can set this bad boy equal to 0 and factor it. Okay, add y squared to both sides. So we get 2y squared, subtract 2y from both sides, minus 6y plus 4 equals 0. Factor out a 2 to make life easier. We get y squared minus 3y plus 2 equals 0. Now $5 says we can factor it because I bet it was carefully crafted to cross at nice whole numbers by you know who. No, it wasn't me, Stuart. Y times y is y squared, and 2 times 1 is 2. And both negatives work, so look, nice whole numbers, 2 and 1. We have done it. It goes from 1 to 2. So this 1 is here, and this 2 is here. So this sketch is very rough. It's a very rough sketch. So, but it gives us enough information to set up our integral. Our integral, the inputs go from 1 to 2. And if the inputs are the y's, the larger curve is on the right. The larger curve is the 2y minus y squared. The smaller curve is the red curve, and that's y squared minus 4y plus 4. Now we'll do a little simplifying, and bam, boom, bam, plug in 1 and 2, maybe take an antiderivative or 2, and we're done. Okay, be careful of your signs. 2y minus y squared minus y squared plus 4y minus 4. I just distributed my negative. Now I'm going to combine some like terms. Negative y squared and negative y squared is negative 2y squared. Okay, and then 2y plus 4y is 6y minus 4. I'm getting a little slanty. Okay, maybe I'll straighten it out. Okay. That didn't work as well as I'd hoped. Okay, maybe we'll straighten that out. Okay, one more try. I don't know why it's not working. Okay, now we'll happily take the antiderivative. Negative 2/3 y to the third minus 6 over 2, 3y squared minus 4y. And we'll happily plug in, actually we won't. Plugging in 1 and 2 sounds kind of like a bear. Maybe we won't happily do it. We'll do it, but not happily. 2 to the third is 8, times 2 is negative 16. Minus 2 squared is 4, times 3 is 12. Minus 4 times 2 is 8. Why didn't they make this one 0? Stuart. 1 to the third is 1, times negative 2/3 is negative 2/3. Minus 1 squared is 1 times 3 is 3 minus 4. So negative 16/3 minus a negative, that's plus. Negative 16 plus 2 is negative 14 thirds. Negative 12 minus 8 is negative 20. Minus a negative 3, that's plus 3. Minus a negative 4, that's plus 4. So 3 plus 4 is 7. Okay, so negative 14 thirds minus 20 plus 7. So negative 14 thirds minus 60 thirds plus 7. Negative 64 thirds plus 21 thirds is negative 43 thirds, which means most of the area lies behind the y-axis or something like that. Okay, I was going to double check my answer, but that is a example problem, and I can't. I know I have the right idea. I was worried I missed a small detail, but we'll never know. So everything's fine.